Good afternoon, everyone, and welcome to the third installment of CBT's Hygienic Design video series. Once again, I'm your host, Larry Hecker, one of the belting specialists here at CBT, and also our in-house hygienic design specialist. And today, I'm going to have a guest, Kevin Guernsey from Interlocks. Interlocks is one of our very best vendors. They're just a wonderful company on the cutting edge of technology within the field of conveyor belting and conveying solutions. And we're real excited to have them today. And they're going to share some really neat new stuff that they've come up with that will really help our customers with sanitation and be able to keep their plant floor running much more safely than possibly what was available in years past. So, Kevin, welcome today.
Hey, Larry, thanks for having me. Looking forward to the conversation.
So, Kevin, tell our listeners your background, what's your job title, and exactly what you do there at Interlocks.
Yeah, so I am Kevin Guernsey. I direct our global R&D efforts for our meat, poultry, and seafood team at Interlocks. I've been with the company 23 years now, and mostly spending time in the meat, poultry, seafood industry in my career.
Okay, well, welcome aboard. And again, thank you for your time today. I'm looking forward to asking you some questions and learning some stuff that I didn't know about before today. So today we're going to talk about shaft optimization. And Kevin, can you kind of tell me what that is exactly?
Sure. It's so people might hear that term shaft optimization and immediately think of shaft engineering, where you are, sizing a shaft accordingly, given loads and torques. That's not what we're talking about here today, Larry. Once we have the shaft engineered to drive modular plastic belting, it's very important that you have a positive drive system utilizing sprockets to make that belt work. And so how you set up that drive shaft and idle shaft are absolutely critical in obtaining the optimal belt performance. And so when I bring it back to what shaft optimization is, it's that shaft setup to properly drive the shaft. It's a set of very simple components that actually solves or prevents some pretty big problems if it's not done properly. And I'll explain more about those components as we talk here, but it really is focused around the shaft drive and idle setup for modular plastic conveyor belting.
Okay. Well, why did Interlocks decide to develop this concept?
It's a great question because this is an evolving topic for us at Interlocks. So years prior, we would recommend to put your sprockets on the shaft, lock the center one in place so that it has a feature the sprocket has a feature that engages into the belt called a tracking tooth or tracking feature. So once that sprocket is on the shaft, locked in place in the center, it's positively locked into the belt. So when you're running the system, it tracks the belt true. So it keeps the belt running straight during production. So we would recommend locking the center sprocket and then letting your other sprockets float on the shaft for thermal expansion and contraction. So that was our prior recommendation, Larry. And over the years of what we've seen with our hygienic modular belting is that, especially in the meat, poultry, seafood industry, where those systems are cleaned up every night, the belts can oftentimes be lifted off of the drive shaft or removed completely for a cleaning cycle. And this happens every night in the meat, poultry, seafood industry. And so with our prior recommendation, what we were seeing happen is that once a belt was removed from that sprocket and then cleaned with high pressure water, all of those sprockets that we prior would say allow flow for thermal expansion would actually drift all to one side of the shaft, causing those big problems I was talking about earlier. So when you have sprockets that migrate to one side of your conveyor, you now have uneven load distribution through the system. You can get higher stress concentrations in certain areas. The belt, once the sprockets are sort of pushed to one side, does not want to track properly anymore and can start to drive the conveyor belt into the frame, causing a potential foreign material contamination risk if the belt's wearing and shaving or rubbing against the frame. And so it's very important to prevent any of those issues that you follow this shaft optimization, this new shaft optimization recommendation to prevent those problems I described. And Larry, we, as the Foreign Material Challenge, has really been at the forefront of conversations in the meat industry for the last few years. We went out looking at probably over 1,000 conveyors to analyze the kind of root cause of why a belt could potentially become a foreign material risk. We were able to bucket sort of all of the issues, the root cause issues, into 5 categories. And this sprocket setup was one of those top 5 categories that we see almost every plant we go to. So it's absolutely a critical part of the system to get right to ensure the optimal performance, to mitigate any sort of risk of damage to the belt and system.
So how is your setup different than what myself or any other CBT salesman would see out in the field right now from either old interlock setups or our competitor setup?
Yeah, so again, the prior recommendation, we always were recommending to utilize our drive sprockets. That's an absolutely critical part of the system to get that positive engagement with our belting. We would then recommend locking the center sprocket down, as I mentioned prior. And you oftentimes see really a hodgepodge of materials being used to lock sprockets down in place. So I see everything from hose clamps to zip ties to key stock welded on a shaft. There's a number of makeshift methods, I would describe them, to hold a sprocket in place. And those are not effective at all. We actually have seen a number of hose clamps that they won't hold the shaft. They don't have enough holding power, essentially, if there's any side load on the belt. So, and it wants to move that sprocket laterally on the shaft, a hose clamp's just not cut out for the job. And so the sprockets could still migrate. We've seen hose clamps actually break and become foreign material contaminants themselves. And so it really was a lack of the proper tools and components necessary to achieve this optimal setup that just didn't exist before, Larry. You have retainer rings, snap-on retainer rings. Those are some of the better options. But for those sprockets that were not located in the center that we wanted to float for thermal expansion and contraction, because that's an important part of the setup. The belts will grow and shrink in the width as the temperatures change. And so for somebody like meat processors, that's important as you go from room temperature down to 40 degrees F for processing, back up to probably 90 to 100 degrees during sanitation. And so those belts are moving. So the sprockets that are not central to the system, we still need those to be able to move around and float for thermal expansion and contraction. And there's just not been a good solution for those sprockets. Like I said, there's been some retainer rings and lock collars, and then even makeshift methods, which are not good. But some other solutions just did not exist before to go between those other sprockets, keep them in place, and keep your outer sprockets from drifting off the shaft.
Okay, so we talk components. What components are needed for a fully optimized shaft?
That is the critical piece of the system, are these components. So it starts, Larry, with we first have to get the number of sprockets on a system right. So the number of sprockets will change given the application and load requirements necessary. So as your load goes up in an application, so does the number of sprocket requirements. So that's step one in our setup and our configuration. So you need drive sprockets, idle sprockets, and you absolutely have to have the right quantity given the application. Next, we recommend our heavy-duty lock collars, which would be used to lock the center sprocket down, as I described earlier, sort of performing the main tracking function of the system to keep that center sprocket locked. It's engaged with the belt, so our belts are driving true and straight in the system. So we recommend 2 of those lock collars at the center sprocket, and we're now recommending 2 more of those lock collars at the outer positions of the shaft to keep sprockets from migrating off the shaft completely and dragging into the frame, rubbing into the frame. And so all of the setups will have 4 lock collars, 2 central, 2 outboard. And then we have a new product, which are called food safe spacers, which go between those other sprockets that we need to float for thermal expansion and contraction. And these spacers are, again, configured based on the number of sprockets you have in the system and the given spacing of those sprockets. And they're meant to go in between each sprocket to keep them from bunching up if the belt is taken off and cleaned with high pressure water. And the important thing here, Larry, is that for modular belting, it's not critical that those other sprockets are sort of dead on in an accurate position. Modular belting is actually pretty forgiving in that sense. But so the spacers actually have some room in them for cleaning and sanitation. We don't want to jam everything in there tight where you can't get at it to clean. These spacers allow for cleaning. They allow clearance for thermal expansion and contraction. And you still have some fault tolerance built in if it's not exactly in place. But it's darn sure going to keep those sprockets from migrating and bunching all to one side if that belt's taken off for cleaning and sanitation. And I like to borrow a phrase from the infomercial world when I explain this to people. It's like, I mean, truly, once you have this shaft optimization and configuration in place, you can set it and forget it. I mean, it literally is that foolproof. And and again, being one of the top 5 factors that can cause issues. And these belts are going to go through cleaning sanitation cycle every night. It's imperative that this system keep all of these sprockets in place, again, to optimize the performance of the system and mitigate that risk of any chance of belt breakage, damage, form material, downtime, any of the issues you might have with a catastrophic event.
So I know those spacers are made in different materials. Can you let my audience know what those are made out of?
Absolutely. So the new spacer is made out of a dual detectable acetal material. So acetal has been one of our most common materials for belting and sprockets for several decades now. It's just a very good engineered polymer. We, again, with foreign material being a concern of customers, we opted to provide this in what we call the dual detectable material. Or form of that acetal. So by dual detectable, we mean it has additives in it to optimize its ability to be picked up in a metal detector as well as an X-ray detector. So there's actually two sets of additives in there that work best with each one of those technologies, Larry. If the chance of something happening to those spacers or they break or something would be picked up in a detector. But it's highly unlikely because of where they're located. They're kind of protected by the sprocket. They sit inboard and are smaller. So we think there's an extremely low likelihood of something happening in these, but never underestimate a meat plant. It's a pretty tough environment. I'm sure you're aware of. Yeah. And so we're again building in fault tolerance. I mean, that's the whole idea of this entire system is you set it up, it brings extreme fault tolerance to an already fault tolerant product in modular plastic belting. But if something does happen, we want to make sure that the customer has that added protection of being made out of detectable materials. And our lock collars, the heavy duty lock collars are stainless steel. So will be detectable as well.
Okay. I know when those spacers first came out, we had a choice of either metal detectable or X-ray detectable. Are those still available, or is it just going to be the one material now?
They are. So for our ThermoDrive product line, we have a set of spacers where they're each available. But yes, we are moving towards this new universal material to cover both, keep things simple.
Now, what shaft sizes do those spacers fit on? Both the 1.5 and 2.5?
So right now it's 1.5 and it's metric cousin 40 millimeters. So we do not have 2.5 at the moment. Certainly, as an R&D guy, that's on our radar, as well as being asked about round shafts as well. So,
right,
we see certain challenges there, and with return way setups where your round shafts are being used, which spacing is also a concern. And so something on our radar, Larry, is to continue adding more of these spacers where needed. Yeah.
So right now, 1.5 square shaft are what these are available in.
Correct.
For now, but hopefully in the future, the 2.5.
Correct.
Okay, good. So how can CBT and Interlocks work together to provide shaft optimization assistance?
Yeah. So Larry, we have at Interlocks, we had to develop a kind of a simple program to configure the setup. So we have several different widths of spacers. And just as I was explaining before, as the number of sprockets change, so does the spacing, so does the spacer that's being used in that configuration. And so we have a configuration program to help you, Larry, your customers get the configuration correct. So the proper number of sprockets, where those spacers go, where lock collars go, and we can provide a drawing of that configuration to you and your customers of exactly what's needed and exactly where it goes on that shaft to make sure you get the setup correct.
Awesome. That is a wonderful tool. And again, to let our listeners today know that Interlocks is continually to come up with new ways of conveying product that are hygienically designed so that our food manufacturers know that what they're putting on is cutting edge technology, and certainly as cleanable as things can be in this day and age. So I appreciate your time today, Kevin. I've learned some stuff today, and I know our listeners has. And again, thank you for your time, and we appreciate you providing us with some knowledge of shaft components that can really help our customers out as a real problem solver.
Absolutely. Pleasure being here, Larry. Thanks for having me on.
Great. Thank you. And good afternoon, everyone. And we'll look forward to talking to you again. Thanks. And that's it. Good job, Kevin.
Okay. Yeah. Thank you.
I appreciate your time. And again, we'll oh, wait a minute. I've got one more question to ask you, and this will get edited in. Okay. I just saw this question that Callie threw out there. So I'll ask you another question. Feel free to answer it, and we'll just edit it in where we need it to be. So, Kevin, you've mentioned the 5 contributing factors to plant floor issues in the food and beverage industry. Can you tell us about the other 4?
Absolutely. So sprocket misalignment was the one we've covered here today, Larry, in this topic of shaft optimization, how to get it right, make sure it stays right. The other areas we see challenges with are in the conveyor design and setup. That's a broad topic. I understand. Yeah. But for modular plastic belt, we oftentimes see that screw take-ups being used still, belts being run under tension. That's going to create some real challenges. So that's the main sort of topic in the conveyor design and setup. The use of chemicals, Larry, has really proliferated over the last number of years in the industry with the use of, or continuous use of antimicrobials in the process. And that takes a toll on any material in a plant. And so we've noticed that, extra chemical resistance because of the proliferation of these chemicals being used is an important topic for us and something we've made some improvements on with our belt materials. The third area is just general belt handling. So as we talked about the, meat, poultry, seafood, every day you're going through a cleaning cycle. That means the systems are going to be touched. They're going to be handled. Belts could be lifted, could be taken off completely, as these plants have to clean to a microbiological level every day before they start production the next day. So our belts, our systems are handled frequently. And being able to provide more assistance, more tools, more components to help in that area has been another one of our focuses. And then the fourth other point here outside of sprocket misalignment is catch points. we see this all the time in conveyors. You know, you may have a bolt head sticking out that a bearing may be mounted to, or some additions have been made to a frame over time that now protrude into the belt's path. And if you have sprocket misalignment issues and the belt's not tracking true and it's driving into the frame, it's just, those issues are going to exacerbate any sort of damage to the belt. So those are our 5 topics. And like I said, it took us a number of months out looking at probably over 1,000 conveyors to see the commonality in the industry and really bucket them into these 5 topics and then go attack them with our product development team.
Yeah, I can, from my experience, most of the time when I'm called into a plant to look at a modular conveyor because they're having issues, it's simply a poor design to begin with that has created the issues that my customer is dealing with. And I keep telling my customers and people that design conveyors, make it as simple as possible. It seems like every conveyor I look at where we're having problems, they've got an over complex drive setup and take ups and this and that, to the point where they've created their own monster. And generally the solution is we just start yanking off components and simplifying things to make things work again. So yeah, I can imagine when you go out and look at 1,000 different conveyors, you probably saw 900 of them that weren't designed properly.
Yes, sir. It is a challenge. And like I said, modular plastic belting is extremely fault tolerant. That's one huge advantage. But absolutely, there's some just fundamental conveyor setup things that need to be right to make sure you're getting the most out of that belt's lifespan and mitigating this risk of any sort of downtime, damage, for material concerns as well.
Okay, great. Again, appreciate your time today.
Yeah, thanks for having us. We appreciate it.
All right, thank you.
Okay, bye-bye.
Bye.